Hi, I'm Andy Peel from CCDC. Welcome to this video on accessing and displaying symmetry information in Mercury. Symmetry is of central importance in crystallography, and Mercury provides powerful options to visually overlay the symmetry elements of a given space group on the structure being viewed. Mercury also makes it easy to retrieve information about symmetry generators and to distinguish molecules based on their symmetry relationships. To get started, open Mercury and load a structure from the Structure Navigator, or open your own structure file from the File menu, or by dragging it and dropping it in the Visualizer area. For this demonstration, I'm going to use the structure of aspirin, which has the ref code ACSALA. This structure exists in space group P21C, and toggling packing on in the display options reveals that there are 4 molecules in the unit cell. To view the symmetry elements graphically, from the top menu select Display and Symmetry Elements. By default, Show Symmetry Elements is enabled, and the various symmetry elements will appear overlaid with the structure in the visualizer. You can toggle the various options on and off, one at a time for greater clarity. The glide planes are currently coloured pink, the screw axes are green, and the centres of inversion are orange. The presence of the half arrowheads along the green lines indicates that these are screw axes rather than proper rotation axes, and this can be confirmed by toggling screw axes on and off. You can customize the color of the symmetry elements by clicking on the color button, and the slider can be used to adjust the transparency for ease of visualization. We'll now turn off the symmetry elements display and look at some other useful symmetry features that are available from Mercury. From the Style and Color toolbar, in the Color drop-down menu, we can select Color by Symmetry Equivalence. All molecules appear in the same color, indicating that they are all crystallographically and therefore chemically and geometrically identical to each other, so they're all symmetry related in this structure. We can dig down into this deeper by selecting Color by Symmetry operation. We now see that each of the 4 molecules has appeared in a different color. The colors represent the symmetry relationship to the asymmetric unit, which is colored in light gray. If we now click More Info from the Display Options toolbar and select Symmetry Operators list, we can see the list of symmetry operators in our structure with a detailed description of each. The color key next to each operator is also representative of the default color used to indicate the symmetry relationship between the molecules when coloring by symmetry operation. If you click Customize, you can rearrange the fields in this table and remove or add any as you wish. We can now turn on the symmetry elements display again to show how coloring the molecules by symmetry operators helps us identify which molecules are related by symmetry operations and where the symmetry operators are located. As a second example, we can look at the structure CBM-ZPN12, a monoclinic polymorph of carbamazepine. The unit cell contains 8 molecules, and selecting Color by Symmetry operation shows that there are 2 sets of 4 molecules. Can you use the symmetry operators list to explain why this is so? To summarize, there are numerous ways to explore symmetry in your crystal structures using tools within Mercury. You can try this functionality and explore symmetry in your own structures, or practice with the ref codes you see on the screen. The tools shown in this video are available with the free version of Mercury. Find out more information on Mercury from the links in the description below and in our free CSDU module, Visualization 101, Visualizing Structural Chemistry Data with Mercury. Thank you for watching, and don't forget to subscribe to our YouTube channel.